All right, I think I'm audible and visible now. Hi Ragul, hi Hita, hello Hari Prasad, hello Lalita. Good evening legend. Hello Nidhi, hello Sasiswati. Welcome future pilot. Good evening Alvin. Welcome to this legend series. And I had put up a poll on the community of our channel long time back, asking students which chapter or which topic do you want to revise for your midterm, for your JEE, for your NEET examinations. So most of you voted for Newton's laws of motion. And there you go. Here I am with the chapter of Newton's laws of motion in this one shot, where I'm going to help you understand this chapter, help you solve the problems in this short, sweet and direct lecture. Okay. So those of you who do not know me, my name is Shreyas. I've been teaching for a very long time. I'm also leading the JEE division of physics department at Vedantu. And I'm very proud and extremely happy to say that many of my kids are doing extremely well in their different fields of life after passing out from the prestigious institutes, be it IIT, be it NIT, be it BITS or IIITs. So now it's your turn to make me proud, to make your parents proud, to make your relatives, your friends also proud. So before we begin, do not forget to smash the like button and also hit the subscribe button. Good evening Nitin, nice to see your display picture of warriors. Hi Solankis, hello Joyce Mary legend, hello legend, good evening, long time guys. I'm very good Hita, good evening, thank you Charita, hi Ragul. So in this chapter, most of the concepts are there which are going to be used again in the chapter of circular motion or work power energy or even rotational mechanics and even your collisions chapter. So it's a very fundamental and very important chapter that you should know. Also at this point of time, I want to congratulate all the students, your seniors who have made us proud. 2,688 students who have qualified for JEE Advanced and more than 1,500 selections this year also in JEE Advanced and more than 1,000 selections in NEET 2022. So these are your seniors. So guys, the reason why I showed you this slide is because I want you to believe not just in yourself but also in the institution where you are studying, because if these students can, you too will be able to do it next year. Now quickly, Newton's first law is all about inertia. And guys, can you quickly put up what is inertia and how is inertia measured and what is the difference between mass and weight? Maybe you can put it up in the chat box. Varun, Udata, this is not exactly the first lecture, you can say. I have conducted a series last year also. There is a beautiful playlist called as Nurture in which I have taught Newton's laws. This is more like, for all the students who want to attend the lecture live and want to revise the concepts and want to see how the problems are solved and what are the different aspects of Newton's laws. That's why this lecture is there. Yep, laziness of a body, correct. And this is what first law is all about. And there is a condition for the first law, and that condition is balanced forces. So if the forces are there but they cancel out, then you will see the body will maintain its state. And I say state, it does not mean liquid, solid or gas. It means if it is moving, it continues to move. If it is at rest, it stays there at rest. That's what the first law is all about. The second law is about what happens when there is an unbalanced force. So the first law was about equilibrium, when it maintains. The second law is when it is not in equilibrium. Equilibrium means it stays as it is, does whatever it was doing. When it is not in equilibrium, the forces will definitely not cancel. Like the apple which fell on Newton's head, that was definitely not in equilibrium. There was an unbalance, and that unbalanced force was by the weight of the earth. So whenever there is an unbalance, you will see that there will be changes in the momentum. And how quickly the momentum changes, that decides how much force is being acted upon. So net force is the rate of change of momentum, and also remember, force is mass into acceleration. That's another way of expressing Newton's second law, right? Very good. I can see all of you are already putting up the definitions and your own version of the first law. Very good, Varun, Astrophile, Takshin, Legend, Surya, Charita, Goober. Yep. Oh, no, Hita, F is not mv, F is dmv by dt. So when you differentiate it, you will get mass into acceleration. The third law, a lot of jokes are there in many pages and many, sites, that when you slap someone, you also get back a slap. So that's basically karma. So karma works basically the way if you do something good, good will also happen to you, and if you do something bad, bad will also happen to you. Action, reaction. So if I apply some force on you, also you will apply a force on me, whether you like it or not like it. So one force is action, the other force is reaction. There is only one exception to Newton's third law. There is only one force which does not follow third law, and which is that force? Let's see how many of you are able to think about it. Thank you, Surya, so much. Yep. Hello, Vasudha. Hello, Vijay. Thank you so much, guys, for joining in, and make sure you are subscribed on the channel, and you please watch my last year's playlist I have made for you. The physics playlist is a beautiful playlist of all the lectures, all the chapters, all the topics covered for JEE and NEET. Okay. Yep. So the only force which does not follow Newton's third law is the pseudo force. Pseudo is a force which acts in an accelerated frame like a falling lift or an accelerating car. In those frames, I will talk about it also in a bit. That pseudo force is a fictitious force. It's not a real force, so it does not obey third law. All other forces, be it friction, normal, weight, etc., they all follow the Newton's third law. Okay, they always exist in pairs, equal and opposite, but they will not cancel each other, because if action acts on this body, reaction acts on the other body, so they will not cancel each other because they are not on the same body. Keep this in mind. Great. Centrifugal force, pseudo force, all are, yes, fake forces, fictitious forces. They will definitely not obey the Newton's third law. Just like when you jump out from something, that thing from which you are jumping out is being pushed backwards because of action and reaction. Now, the main part of this chapter is free body diagram. That's the first thing that you should know. If you cannot identify the forces, draw the free body diagram and then write the equations and solve them, then there is no point doing this chapter. So this whole chapter revolves around free body diagram. And yes, the free body diagram has different forces, and sometimes the forces become very large in number, especially when there is acceleration, when there is spring and tension and so many other things, or multiple pulleys. So let's start with some free body diagrams. So when I say a free body diagram, it means showing all the forces acting on the system or by the system. Come on, put it up in the chat box. Nisha is saying it will act opposite to the acceleration. No, nothing like that, Nisha. There is nothing like it will act opposite to the acceleration. If for example, I push this bottle this way, then the bottle will push my hand back this way. So the force which my hand applies on the bottle is this way, towards your right. The force which the bottle applies on my hand is towards your left side. So it's opposite to the force which you are considering. Any one force you can call action. The exact opposite on the other body is being called as the reaction. Yes, on the system. Very good. Always on the system. Never show forces by the system. That's very important. So let's try to understand certain important aspects of free body diagram. I'm going to give you certain important systems, and then we are going to draw the free body diagrams. So be with me. Lots of questions, application, concept, everything you'll understand if you follow the lecture properly. All right. So imagine, guys, this is Pandu. All right. This is Pandu. He has certain mass and he's standing on the earth. He's standing on the earth. This is earth. I know Pandu is looking very huge, like a dinosaur compared to the size of the earth. This is highly exaggerated just so that you are able to visualize it. Nothing else. Pandu will be small only. Now, if I ask you to draw the free body diagram of Pandu, like, sir, why are you giving such a simple question? But let me tell you, many students make many mistakes in this, and you will learn many concepts just by the simple free body diagram. So look at this. The forces acting on Pandu are his own weight. Weight is the force of gravity. Gravitational pull is there. So the weight acting on him, which will be nothing but m times of g. That's the weight which will be acting down. M is the mass, g is acceleration due to gravity. And he's standing on a surface. So every time you put something on a surface, there is a reaction that is called as the normal force. So obviously there is going to be a normal force. Now I have a question for you. If I call this normal force as the action, as the action, can you quickly tell me which is the reaction? I know, right? Pandu is very handsome than me. I know, he does not even have hair, but he's so cool. Yep, average student can also crack JEE Advanced if you do a lot of hard work and solve a variety of questions. So guys, think about it and tell me, if normal is the action, then which is the reaction force? A lot of you might be wrong, a lot of you might be correct. I want to know which one is the correct answer. Hita saying mg. Hita saying mg. What about others? What about others? Well, if you guys are thinking mg is the answer, that's definitely wrong, because I'll tell you why. If I draw the free body diagram of the earth, then understand there will be forces like this on the earth, because Pandu is standing on the earth. Pandu is being pushed up by a normal force. The same normal will also act on the earth like this. So there will be a normal force exactly like this, and there will be one more force, which is the weight. If Pandu is being pulled down by the earth, Pandu will pull the earth up. Pandu gets pulled down by gravity. Pandu also pulls the earth up like this. So there will be another force, which is W, which is also numerically equal to mg. So if this is action, my dear students, then this normal is the reaction. This normal is basically the reaction. A lot of people thought this weight was the reaction. No, that is not the reaction. If this is action, this normal is the reaction. Equal opposite forces acting on different bodies which do not cancel each other. Same way, if I call this weight as, let's say, the action force, then this weight becomes the reaction to that particular weight. Did you now get it? Everybody with me on this? Yes, I do know, Aditya sir, Vijay. Yep. Yes, इसी के लिए करा लो. और Lalita, I'm doing the exact same thing for your half yearly. So for that only, for 11th and for 12th, whichever topic you want, please put it up in the comments after the video ends. Awesome, guys. Now, imagine I give you another question. And here, this time, there is a tug of war between two teams. Let's say, for example, one team is of Pandu. This is your Pandu. All right. That's a tug of war. And there is Champa on the other side. There is this beautiful Champa, like you can see. So pretty. All right. So this is beautiful Champa like this. And she is competing against Pandu because Pandu challenged her for a tug of war. Okay. Now, let us say, for example, whom do you want to win? Do you want to make Pandu win or Champa win? Vijay, focus on the class, man. Don't worry about whether I want to grow the beard, I don't want to grow the beard. Why are you bothered? Okay. I don't want to copy anyone. Okay? Everybody has their own style, bacha. So please focus on the class, not on the beard now. Alright. So, Pandu and Champa, whom do you want to win? You want to make Pandu win or Champa win? Come on, think about it. Pandu, legend Prachi says Pandu wants to, she wants to make Pandu win. So, okay. So, for example, Pandu versus Champa. Okay, people are confused. Okay, let's make Champa win for this time. No problem. Let's make Champa. So, let's say Champa is the winner. So, Champa wins and Pandu basically lost the tug of war. So, Champa is pulling Pandu like this. Pandu is getting dragged. By Champa. Now, I ask you a very simple question. Which force is more? The force which Pandu applies on Champa or the force which Champa applies on Pandu via the string? Basically, the force of that string. Which force do you think is more? Which Pandu applies on Champa or which Champa applies on Pandu? Which one do you think is more? Should I put more than, less than, equal to? What do you think? Power of Champa. Hello, Aswita. Both are equal, says Varun. Excellent. The correct answer is both these forces are actually equal. You will be like, what nonsense is this? I thought one will be more, one will be less. Because Champa won. So Champa has applied more force. Sir, what are you saying? If I give you my hand, you're sitting over there, and I pull you like this, you will be like, sir, you applied large force, sir, on me. And the force which I applied on you was less. That's why I got pulled on this side. If I give you my hand and pull you like this, you will say that I applied more force than you did on me. That is completely wrong. Both of us applied same force. Then you will be like, what nonsense is happening? So let me tell you over here what has happened. There is this force of tension because it's a string. It's taut, it's tight, it's being pulled. So the string also pulls Pandu. It's the same string. So you will see that the same tension is being applied over here. In fact, both these forces will be equal to the tension. This is the tension in the string. Then you will be like, how did Pandu lose and how did Champa win? What's the reason behind it? The reason is basically friction. See, weight and normal are there, but those are in the vertical direction. So you should not bother about it so much right now, especially for this question. Because the motion is horizontal, I'm not bothered so much about the normal or the weight. Here, why did Pandu lose is because the force of friction on Pandu was less as compared to the force of friction on Champa. So look at this. If you consider only Champa, the force on Champa by friction was more than the tension force, because of which the Champa accelerated or moved this side. So that force was more, this force was less. So Champa was able to move towards that side. Here what happened was the force by friction on Pandu was less than the tension force. That's the reason why tension was higher, which was able to move Pandu towards this side. So friction was less. He did not have a good grip. So grip plays a role over there. So no matter how strong or powerful you are, if you are standing on a smooth surface, you will definitely lose in tug of war. So always in tug of war, it's said you should have a very, very good grip. Exactly. All right. Awesome. Yes, Pandu lost due to friction. Great. So don't worry about JEE 2023. I will make an announcement very soon on my prediction date for JEE 2023. Stay tuned. Make sure you are subscribed on the channel, bacha. Next important thing. All right. Observe these things very carefully. You are going to learn a lot through these questions. Interesting thing. Imagine that I have a string like this. I have a string like this. This is a string. And what happens is that I apply a force F over here and I also apply a force F over here. My question to you is, what is the tension in the string? If both had equal friction, legend, by chance, then legend Prachi, what will happen? None of them will win, none of them will lose. It will be a tie. They will just keep on playing until one of them just gives up. So that's what will happen. Yep. I'll come on contact force also. Vijayan, you can learn any physics course from me for 11th, 12th droppers, JEE, NEET boards. Obviously, there's a beautiful playlist, Nurture, for 11th, 12th. It's called Pathfinder. It's there. Please watch it. You will learn a lot through all these detailed classes right from chapter 1 to the last chapter. All right. So in this case, Varun is saying 0. Hi, Spidey. Hi, Pi. Maybe I'll answer your questions maybe later on. All right. And same thing, Satvika Madari, leave a comment, bacha. Right now I'm concentrating on this class. So I'm looking at only your answers and anything that you are asking related to the questions or the theory that I'm teaching here. Answer is 0, wrong. A lot of people are saying 0. The tension is definitely not 0. In fact, the tension force is equal to F. A lot of people got wrong answer. I'll tell you why you guys got a wrong answer. See, understand, when I show this diagram, many people think force F cancels. That's why net force is 0. That's it, done. That's not how it works, my warriors. Look at this diagram. If there is a wall and there is a string over here, and then I apply a force F over here, and now I ask you, what is the tension in the string? Immediately you will pounce and say, sir, you are pulling with force F. Obviously the tension will be F itself. Then my question to you is, why did you say here the tension is F and over here the tension is 0? You're like, obviously you are pulling here, obviously the string will develop tension. There you are pulling it from both sides, that's why sir, no tension. Then I will give you tension. Not that tension, but tension in your mind. See how this works. If this string was attached to the wall, won't the wall also apply some kind of force over here? And won't this force, the reaction by the wall, won't be equal to F? Won't it be equal to F? If you are pulling the string here, the wall will also pull the string back over there. Isn't this diagram same as this diagram? That's it. Isn't this diagram same as this diagram? What's the difference? One of the force is a supporting force, the other force is the pulling force. Imagine there was no force on this side and you apply only one force. Gone, the string will just fly off. Without the second force, if only one force was there, it will accelerate, unbalance. Think about it, Newton's first law, second law. Unbalance will be there, it will fly off. So hence, you need a supporting force to hold it over there. Is that clear? Hello, Jebelen. All right, Aswita. Yep, so tension, there is nothing like total tension. Okay, there is nothing like total tension, please understand that. It's either tension in the string or not. So, whenever you have a string, be it on a pulley, whatever, let's say there is some diagram like this, all right, some crazy diagram. These are all pulleys which are fixed. There is one string which is going like this, like this, like this, like this, like this, like this. Okay, so if I happen to pull this point with some force F, believe me, it is the same string passing all over. This side should also have the same force. In fact, at every single point, whatever value of tension I will get will be equal to F. Pulley just changes the direction of the force. So if I open them up, it will become one flat string like this. Pulley just changes the direction of the force. So if I open them up into one straight line, force F from here, force F from here, throughout at every single point there is tension. Tension is the stretching force at every single point on that string. So at the last point also there will be same tension. Anywhere in between also there will be same tension, that is F. Is that clear? Full of tension everywhere. Lost my mind. Interesting. Oh. Now, never use the word total tension. So you understood that that is a wrong thing. So all these things you would have missed if you had not attended this class today. I have one more question for you. Just imagine that I have a pulley over here. Just imagine I have a pulley over here. And then what I have is basically a string which is probably going like this, wrapped around like this and going like this. All right. Now think and tell me, if I tell you this point has tension T1, the same string is going here. Obviously this string will also have the same tension T1 because it's the same string, correct? This is a completely new string. So I'm going to assume the tension in this particular string as T2. So quickly tell me, what's the relation between T1 and T2? Is T1 thrice T2, T2 4 times T1, T1 twice T2, T2 is half T1, whatever you think it is, please reply to me in the comments. What do you think is the exact relationship between them? Come on, think carefully and let me know in the chat box, guys. Whose tension is more, whose tension is less? These sessions are very important conceptual sessions which are important for you to solve problems. Who is double? That's my question. Is T2 double of T1 or T1 double of T2? That also is very important. Who is double? T1 is T2? I don't think so. Okay, if the pulley is massless, assuming this mass of the pulley is 0, if the mass of the pulley is 0, using Newton's law, I can say T1 plus T1 minus T2 is equal to mass into acceleration, but this mass itself is 0, so RHS is 0, so 2 times of T1 minus T2 is equal to 0, so 2 times of T1 will be equal to T2. Obviously this will be twice of T1. So T2 is basically twice of T1. So if this is 3 Newton, this is 3 Newton, 3 Newton, 3 Newton will give you 6 Newton over here. So this string has to balance totally 6 Newton if each one of them was 3 Newton. Understood this? Clearo? This is how it works. You should know this while solving pulley problems. Now, let's talk a little bit about springs also. I'm going to talk about all the concepts, guys, so stay tuned. Very, very important. So let's talk a little bit about springs, something which is very scary for many students. Imagine I have a spring like this, okay? It has some constant K. K is the spring constant. It is also called as the stiffness of the spring. Stiffness of the spring. It is expressed in newtons per meter. It basically tells you how many newtons force you need to apply per meter for stretching or compressing the spring. Cool? And we all know to stretch the spring by a small amount x, you need to apply a force which is equal to K times of x. Great. Now just imagine this. I give you a question this way. There is a spring over here. All right. There is a pulley over here. And there is, let's say, a mass of, let's say, 2 kg. This is 2 kg. And there is again a pulley over here. And again there is a mass of, let's say, 2 kg. Or basically, better, if you don't want these pulleys and all that, think of it this way, that there is a force of 20 Newton over here. There is also a force of 20 Newton over here. Let's say the spring constant is 4 Newton per meter. Now I ask you, what is the extension in the spring? What is the extension in your spring? What do you think is the correct answer? Come on, guys. Come on, my warriors. Figure this out and tell me. What do you think is the true extension of that spring? How many meters do you think? 20 Newton here. What do you think is the correct answer? Vijayant, Vedantu is completely online, but recently we launched a hybrid batch in Muzaffarpur. We'll be launching more hybrid batches in other cities too very soon, where teacher is online, students sit together with a class teacher, and the classes have all digital materials like quizzes, leaderboards, everything. Much different from your regular offline. Okay, 5 meters. Let's see if you guys are correct. What should I take my force as? The force, I should take it as only 20 Newton, because remember, if there is force from this side, there is also the same force from this side. There is no difference between this diagram and this diagram. So I should just say 20 is equal to K into X. So X will be nothing but 5 meter. 5 meter. Very good. Awesome. Nobody should say 0, or don't say it's a 20 from here, 20 from here. Total force is 40 Newton. That is wrong. This concept is very similar to this concept of strings. Now, let us try to see some more things about springs, which is very interesting. Just imagine, somebody tells you that, there is a mass here, there is a spring over here, and there is another mass over here. Let's say this is M, let's say this is 2M, let's say this is K. Let's say it is mentioned that the extension of the spring is some X, and then you leave it. It is left. You extend it by some amount and leave it. My question to you is, once you leave this, will the two masses move, not move, move together, opposite, same direction? What do you think will happen? You stretch the spring, the masses are held. Now you leave the masses from the stretched position. Do you think both the masses move? Do you think one of them will move? Do you think they will move in the same direction, opposite directions? What do you think will happen? Hello Prasad. Hello Vansh. All right, come on guys, figure this out. What do you think will happen? I have a feeling both the masses will get pulled by the same force. Yes. Spring bounced, hard pounced. Wow. Interesting. So there will be spring force here also. There will be spring force here also. Very good. Will the spring force be same or different? Will the spring force be same or different? They will move opposite to each other. Very good. So will the spring force be same or different? Yes, the spring force has to be the same. Excellent. So will the acceleration be same or different? Will the acceleration be same or different? Think about it. I feel the forces are same, masses are different, so acceleration has to be different. So this guy will accelerate by some amount, and I can find that out by very simple logic. I can say that force is equal to mass into acceleration. So A1 will be kx divided by m, and it will be basically this way. For this mass, I can say kx is equal to 2m into the acceleration. So A2 will be kx divided by 2m, but that would be this way. So you can see the accelerations are definitely not same. Awesome. Now, what if I make a very new different kind of question of free body diagram? It's a beautiful question. Let's try to solve this. Just imagine I have a wedge like this. And on that there is this mass, small m, this is capital M, this is your theta, all right? There you go, something like this. Okay. Now, all surfaces are smooth. That means over here, you can assume mu is 0, but over here, let's say mu is there, which is sufficient to prevent any kind of slipping. The surfaces cannot slide over each other because the friction is very good. The mu value is very good. Let's try this question. Let's try to draw the free body diagram. Let's try to find the value of friction. Let's try to find the value of normal, acceleration, every bit of that force and everything about this problem. Is that okay? Let's try to solve this. First of all, if you just take small m in separate and you try to draw the forces, these are the forces that one will see. Obviously, there is this mass m, and you will see that there is mg force below. There is this mg force below, which you can split into two components, one here and one here, and there will be a normal force like this, and this mass is definitely going to accelerate. Now, whenever you show free body diagrams, always try to show the effect, which is the acceleration. Remember, acceleration is not a force. It is not a force. So don't show it on the body, or else you will be confused. Oh, acceleration is a force. No, it is the outcome. It's the effect. So show it separately. When I show the components, this is theta, and this will be mg cos theta, and this is mg sine of theta. Now, many students ask me, sir, how do you quickly know which is cos, which is sine? How do you know which angle is what? I always get confused. Are you also one of those who get confused when you look at these inclined plane problems? Then let me tell you, you have reached the right point of the video. Let me show you how to not get confused on inclined plane problems. There is a simple trick of drawing 4 lines. When you draw these 4 simple lines and divide it into 8 parts, it becomes crazy simple to solve any inclined plane question, especially regards to angles. Let's have a look at it. Observe. If I have an inclined plane like this, okay, this is basically the inclined plane. This, let's say, is the perpendicular to the inclined plane. Maybe the inclined plane makes some angle over here. Let's say I call it theta. All right, divide by 8 rule, correct? Looks like some of you have been attending my previous classes. Sine is away. It's sin to be away. Very good. Looks like you have watched my nurture classes also, Vigneshwar. Very good, bacha. Now also draw the horizontal and vertical. Horizontal, this is horizontal and this is vertical. This is your horizontal line. This is your vertical line. Now it's very, very easy to predict all the angles. Observe, guys. If this is theta, look at this. If this is theta, even this angle will be theta. Check this out. Even this angle will be theta. Observe this. These are 2 parallel lines. This line is intersecting. This angle will be equal to that angle. Simple. Done, done, done. Now if this is theta, automatically this and this will be theta. That's how simple it is. Every alternate angle, not the consecutive ones. This will be 90 minus theta, theta, 90 minus theta, theta, 90 minus theta, theta, 90 minus theta, theta. That's how it is. That's how easy it is to look at these questions. So using this trick, what I did was, I know this is theta, mentally only I can think of it, guys. This is vertical, horizontal, correct? And this is your extension of the inclined plane. So look at this. This is theta. This is theta. This is theta. This is also theta. So that's how I know this is theta. And whichever is closer, whichever component is closer, that becomes cos. Whichever component is far away from theta, that becomes sine. So it is a sin to go away. If you remember this statement, it becomes easy. It's a sin. It's a pap. It's not a good thing to do, to be away from this angle. So it's sine. When you are closer, it's a cos. Awesome. That's how simple it is. All right, great. So now you can find the acceleration, obviously. So the acceleration, you can find it out like this. mg cos theta will be m into a, mg sine theta will be nothing but m into a. That's Newton's law. M gets cancelled, so a will be nothing but g sine of theta. So this is fairly simple. Most of you would have seen these kind of questions. What about this direction? What about this direction? In this direction, I can see that the normal force minus mg cos theta, minus the mg cos theta, there is no acceleration, so that will be mass into zero acceleration. So therefore, the normal force will be just simply put mg cos theta. Great. Now, I don't want to stop here. How about drawing the free body diagram of the wedge? Because you will learn a lot once you draw the free body diagram. So let's try to do this. If I draw the free body diagram of the wedge, okay, this is of the wedge, can you think about all the forces that will act on the wedge? Come on, my warriors. What are the different forces that will act on the wedge? Obviously, one will be its own weight, correct? One will be its own weight. That will be capital M into G. A lot of students are going to say, sir, small mg will also act. No. Small mg acts on small m. What acts on m because of this small m is the normal. Think carefully. Who exerted this normal? This normal was applied by big M on small m. So small m will also apply the same normal like this. So there will be definitely a normal force this way. So I'm just going to show it probably in a dotted line because I'm going to split it anyways. So there will be definitely a normal force. Okay, there will be also, do not forget, a normal force from the ground. Okay, I'm going to call it Ng. And I think there is something missing, and I think that's friction. Where do you think friction will act? Think carefully and answer in the chats. This surface is rough. I have a feeling there will be friction somewhere or the other. Where do you think the friction will act? Okay, if you look at normal has two components. One component is right over here and the other component is right over here. Oh, I'm confused about the angles. No issues. I know the division of 8 method. So I'm just going to draw my vertical, my horizontal. This is like this. This is your inclined plane. So I know this is theta. So this is theta, this is theta, this is theta. So simple now. It's so easy. That's why this method is very popular, guys. Okay. So obviously the downward component will become n cos theta because you are closer. This component will become n sine theta because you are far away. As simple as that. Now think about it. N sine theta is horizontal. If there is a force, this will accelerate. But I know this wedge is not moving. So hence, to oppose this force, there will be an opposing force, that is friction, which will act exactly like this. So this is friction by the ground. This is friction by the ground. Inclined plane, friction there is not there because mu is 0 on the incline. That's what I assumed. Great. So now it becomes straightforward to solve. Okay, this mass obviously is at rest. This whole thing is at rest. It is not moving left or right. So in the vertical direction, if you see, mg is down. This normal is also down. So you can say capital mg plus this normal is equal to normal from the ground. Okay, normal from the ground. This normal is nothing but mg cos theta. So capital mg plus small mg cos theta is the normal from the ground. Therefore, the normal from the ground will be equal to m plus small m cos theta the whole thing multiplied by g. That is what the normal force from the ground would be. Crazy. And lastly, if I want to find friction, I'm just going to use n sine theta is equal to the frictional force, because in the horizontal direction there is no other force. So in the horizontal direction, I can easily say Fg is equal to n's sine theta component, but n itself is mg cos theta. So this is going to be small mg cos theta into sine theta. If you want, you can alternatively write it as mg into 2 sine theta cos theta is nothing but sine 2 theta. So might as well write it as sine 2 theta by 2. So that will be the frictional force in the horizontal direction. That's it. So I found out everything about that problem. How to draw normal? Normal means perpendicular. Always try to draw normal which is perpendicular to the surface. Like for example, this mass, when I took it, this is the surface, always show it perpendicular. For this mass, the normal will be like this because it is acting on the body. Normal is never applied, outwards, it is always applied on the body. So for example, if I draw the free body diagram of this bottle, on the bottle, the normal will be like this. Yes, the bottle will push my hand downwards. So when I draw free body diagram of my hand, the normal will be downwards. That's how it is. Is that okay? Thank you, legend. Thank you, Rohit Badigar. Thank you so much. Hello, Kailash Ponagurdun. Welcome, guys. Welcome. Great. So moving ahead a little bit, we have spoken about all these things. Now, how about something else? Maybe when things are in equilibrium and stuff like that. So what if I have a question where there is an inclined plane, maybe there is a sphere or something. Okay, let's draw a nice beautiful sphere. Okay, and maybe there is an inclined plane like this till here, and like this over here too, or maybe we can just put a V or something, that would be better. This is our ground. Okay, great. And then I want to draw the free body diagram of such a sphere which is being held by two surfaces in between them. All surfaces are smooth. I want to know what is the normal, etc. So let's start with it. First of all, let me draw the radius from here. Let's say this angle is alpha, and also let me draw the radius from here to the tangent, and let's say this side the angle is beta. So alpha and beta are the angles made by the inclines on both sides. How about solving this question? Let's try this out. So for example, the weight of this sphere will act vertically downwards. So I can obviously show the weight acting like this, which is, let's say, m times of g. Everybody fine till this point? Weight is acting vertically downwards. Then think about it. There will be normal from here also and normal from here also. Both sides there will be normal. So this normal will act like this. Let's say I call it NA, and this side also there will be another normal. Why normal is like this? Because it should be always perpendicular to the surface. So this is another normal which is at another point B. That's it. All surfaces are smooth. No other force can be there. This is the complete free body diagram. Yes, I'll come to pulley mass system also. Hold on, optical learning. Yep, I'll come to pulley mass system also. Hold on. Now, imagine this. I split the forces into two directions. One force will be this way. Another force will be this way. This force, I'll again split it in this direction and this direction. The only challenge is writing down the angles now. If you make a mess up of the angles, gone. So use our division by 8 rule and you will get the answer. Think about it carefully, guys. Divide it into 8 parts properly and figure out which angle is alpha, which angle is beta. It's not that difficult. So if this angle is alpha, naturally this is alpha, naturally this is alpha, naturally this is alpha, naturally this is alpha. So all these are alphas. If you look at beta, if this is beta, obviously this is also beta, then this is also beta, then this is also beta, and this is also beta angle. Great. Once you know which is alpha, which is beta, you know which component is what. Like the vertical component over here, because it is closer, so that will be nothing but Na cos alpha. Here, this vertical component over here will be Nb cos beta. Here, this will be sine components. I don't have space, but I'm pretty sure you can see that. So this will be nothing but your N sine beta, and this will be, if I may, N sine alpha, which is horizontal. Did you understand how to draw free body diagrams? Very good. Now you can write equations whatever you want. For example, in the vertical direction, one can say mg, which is down, is going to be Na cos alpha plus Nb cos beta, Nb cos beta. And if you want to write in the horizontal direction, there is no other force apart from these two things. So this is Na, this was Nb. So it will be nothing but Na sine of alpha will be equal to Nb sine of beta. So these are the two equations which will help me find the value of Na and Nb. Cool? Okay, understood? Clear? Let's solve some more questions based on pulley mass systems or even constraints. A lot of students have a lot of questions or misconceptions regarding that. Whenever you see a pulley mass system, let's say for example like this, okay, let's say there is a mass m1 over here, let's say there is this pulley over here, and maybe there is another pulley over here, okay. These are all fixed pulleys, they cannot move from anywhere, okay, they cannot move. And let's say finally there is a mass over here which is hanging. If there is one string, there is only one tension. The moment there are multiple strings, there will be two tensions. Keep this in mind. So in this entire string, there will be one single tension, completely T. And over here, there will be M1 G force. Here there is going to be M2 G force. You need to always assume that one of the masses is moving somewhere. So if somebody says, all right, M2 is coming down, so naturally thread will come down, this will be pulled like this will go up, so this mass will have to go up like this. If M2 comes down, string will be pulled, M1 will go up, right? Okay, so what will happen in this situation is that if you write the equations, remember our Newton's second law is all about net force is mass into acceleration, that's all. So always try to figure out where is the net force. It's always in the direction of acceleration. Where is acceleration? For M2, it is down. So whichever force is in the direction of acceleration, take that as positive. Opposite will be negative. So hence, here I will say M2G force is the larger force, tension is the smaller force, is equal to mass into acceleration. Similarly, over here, you can see this mass is going up. So tension over here will be positive. So tension minus M1G will be mass into acceleration. Solving, you can get acceleration as well as tension both. But whenever you see such questions, trust me, you can always use the opening up method to solve the question instantly. So what is that opening up method? So the opening up method, guys, very, very important. So open up. So you have to open it up, meaning make all the masses stand or sit in a straight line. There is no tilting of string, because what does a pulley do? A pulley just tilts the direction of the force, nothing else. Correct? So pulley just tilts the direction of the force, nothing else. So if you open it up, you will see that this mass on this side will be like this. This mass, after all that twists and turns, you have just made it straight. That's all. Okay, on this side will be nothing but like this. This is your M2 mass. I hope you can visualize it. All the pulleys are just gone. You don't need that anymore. So now what will happen is you will just have one m1g force over here, and over here you will have m2g force. That's it. m1g force here, m2g force here. Now forget that there is tension, because if you treat this entire object like one system, if you treat this like one single system, you can see this whole thing will accelerate like this. This will accelerate this way, this will accelerate this way. Okay, this will be the acceleration of this mass, this will be the acceleration of this mass. If you bend it back again, to its original shapes and sizes, you will see m2 will accelerate downwards, and the moment you bring m1 like this, m1 will accelerate upwards. So this is nothing but the opened up version, and now it becomes easy to solve because net force is mass into acceleration. So I can also say my acceleration is the larger force, larger minus the smaller force, divided by the total mass. So you can directly say larger force in this particular scenario, is nothing but m2g, smaller force, let's say m1g, total mass is m1 plus m2. So this is an easier way to solve the question. If tension and force are equal, then how do pulleys make pulling easier? Okay, so I'll explain that to you in the next concept, guys. When multiple pulleys are there, or just even a single pulley can do the job. Let me explain that to you in the next slide. Is this clear? This concept is clear? In the before case you cannot use it, bacha. It's only for pulley problems. Varun Radha, you'll use it for pulley string block problems, not for anything else. So I will show you some questions also if you want in a bit. Like for example, say I have a question like this. Imagine there is a mass over here, there is this pulley over here, and there is another mass over here. Okay, there is another mass over here. All right, I'm just going to show it like this, m2, and maybe there is another pulley over here, and let's say there is a mass m3 over here. So these are the masses. This is an inclined plane, like you can see. Okay, and let's say this is theta, and let's say I want to find what is the acceleration of the system, because this whole thing will go like this. How can I use opening up method? Within seconds you can find the answer. Let me explain that to you. Yes, you can take G common, obviously, Gopika. Yes, definitely. Before that one, is it? Before that one, what was there? In this one, no, you cannot use opening up method here also. It should be pulley string problems. Here also you cannot use. It should be pulley string problems like the one I am showing over here. Okay, Varun? Now, when you open it up, see what happens. But before that, you should think about the free body diagram. M3G will be the force like this. Forget tension. M2G will be like this. Normal will be like that. Here there will be a normal force. And here mg will have two components. Only take the forces in the direction of the motion. Acceleration, force. Acceleration, tension is there. Tension is internal, so don't bother. Here acceleration is here, so only worry about this force, which will be this was m1, I believe. This was m1, so this should be nothing but m1g sine theta. Here, please understand, the acceleration is like this. There is no force in the horizontal direction. Tension is internal. Don't worry about it. When you open it up, see how it looks. The moment you open it up, what will you see? This mass will become straight. So I will just show m1 like this, connected by a string. Forget this pulley, it's only changing the direction. You will just show one mass over here. This mass, bring it over there like this. So you're going to see this mass like this. This is your m3 mass. Now show the forces. This force will be m1g sine theta. I am not bothered about m1g cos theta or even this normal. Same way, I am not bothered about this normal or even m2g. Here, it's directly m3g. That's all. and this entire system as a whole, you can treat it like one system. So tension becomes internal, which is now accelerating this way. Please realize tension is internal now. Tension is internal, and you never worry about internal forces. Is that clear? Ashwin, if you are not been studying, please watch my lectures, bacha. That's the only way you can be regular. Set up a timetable, set up small targets, study with someone, ask your best friend who is also motivated for JEE or NEET to also help you out and also push you towards your studies. That's the only way, and remove all your distractions in life. You can definitely work hard. I'm there for you. The entire channel is there for you. Now you can clearly see that the acceleration can be written down as, which is the larger force? Well, that's M3G. M3G. M2, there is no force, forget. M1 has an opposing force, so M1G sine theta, you can take G common later on, upon total mass. So M1 plus M2 plus M3, you can take G common also. That's it. Thank you, Jose. That's all, guys. It's that easy to solve the problem. Once you learn how to open up, within one line you will write down the acceleration. You don't even have to write any free body diagrams. I hope this is clear. Alright, now let me tell you how to do questions where pulleys are moving or movable pulleys with multiple strings are there. So say for example, my students, imagine that you have a pulley somewhat like this. It is fixed over here, and let us just say that there is a mass over here. Let's say M1 is connected like this, okay, to another mass over here. Okay, let's say I call it M2. Okay, so this is a flat surface and there is another pulley attached to mass M1. And in these situations, you might generally be asked to draw the free body diagram of all these masses, find acceleration or find tension. Internal tension, what do we mean by that, Ragul? Internal force means those forces which are within the system. Like your heart is beating, there is muscular force, but that is within your body, so it's internal. It's not coming from outside. Because I chose this entire thing to be my system, only the gravity and the normal are external forces. Tension is within these two masses, so it's internal force. So whenever you write net force is mass into acceleration, you never consider internal forces. It's always the forces acting on the system which should be considered. I hope, Ragul, that makes things clear. Okay, so let's draw the free body diagram. It's going to be very nice and interesting. So if you look at this mass on the table, which is M2, and this mass which is not on the table, which is hanging separately, think about the forces acting on them. Like M2 will experience M2G downwards. There will be also a normal force over here, and there will be tension as well. Yep, there is a string, so there is tension. If you look at M1 mass over here, then there will be another tension from here, and M1G will be like this. Great. Now, should I show this tension and this tension as equal or not? Just let me know in the chat box. Just let me know in the chat box, guys. Is this tension equal to this tension? Think clearly and answer this question. Maybe the free body diagram of the pulley will help you out a little bit. If this is the pulley, look at that. The same string is coming like this and going here. So I feel from this side, this tension, that's T, will come. The same string going here. So the same tension will also come over here, right? And the next thing over here, what do you think this tension would be? What do you think this tension would be, guys? Yes, it will be different. Thank you, Brainy Gamer. Okay, thank you, Jose. I'm so glad. So don't worry, this lecture is not over. I'm doing a lot of stuff for you. I'm trying to do as many things, as many concepts as possible in this lecture. Strings are different. TT, 2T. Remember, I had just shown you this concept sometime back in one of the previous questions. Yes, here. T2 is 2 times T1. T1 gets T2. So the same thing over here as well. So this is 2T. So naturally, this tension will be 2T. Now this is a question on constrained motion. Yes, believe me, this is a question on constrained motion, because if this moves something, this moves something else. Now, many of you might have learned by different ways. Some of you would have learned by derivatives, assume lengths, x1, x2, x3, differentiate, find acceleration. Crazy. Second, visualization. Okay, not so crazy. With practice, you will get it. But let me teach you a very simple way. See, whenever you see tensions in the direction of the motion and you know the accelerations are different, all you see is how much is the tension along the motion, how much is the tension along the motion, and just do inverse of it, just the inverse of it, then you will get the accelerations ratio. What I mean is basically, if this mass is going to accelerate, obviously this way, I think this mass will fall down this way. The tension in the direction of motion, see what's the ratio, T to T, the acceleration will be exactly in the inverse ratio, meaning wherever there is 2t, the acceleration will be a. Wherever there is t, the acceleration will be 2a. T is to 2t, a is to 2a, inverse. That's all. Constrained means the pulleys move, they pull other pulleys or strings, because of which the other masses move differently. So here, both these masses do not have same acceleration. So you need to know how are these accelerations related to each other. It's completely geometry based, completely visualization based. So that is called constrained motion, brainy gamer. Okay, so if this is t, this is 2t, this will have a acceleration, that will have 2a acceleration. That's all. So after this, writing equations is not a big deal. Like this mass is coming down, so this will be bigger force. So you're just going to say m1g minus 2t is equal to m1 into a. That's for this mass. And for this guy, there is only one tension, that's it. So tension will be equal to m2 into acceleration is 2 times of a. That's it. Substitute, solve, you'll get the answer. So here what happens is, Ragul, when this mass moves slightly towards this side, this pulley will come down. So look at this, this pulley will come down slightly over here, right? This pulley will come down over here. So you will see this mass will also come down slightly. Oops. This mass will also come down slightly over here. You can see there is a small displacement downwards. There is a small displacement downwards. So because of which this mass will definitely move. This mass will also definitely move, and that will be twice. So if this moves down by x, this will move by 2 times of x. This is constrained motion, where the motion of the others are dependent on the other geometries or other strings, masses, pulleys, etc. because of the way or manner in which they have been arranged. I hope that is fine. So I saw this by visualization, and what I said was, once you know the free body diagram, you can write the equations. How do you draw the free body diagram? Identify the weight, normal, tensions. Tension I know will be basically, if you look at this pulley, this string has T tension. Look at this string. This particular string has T tension. So T. So naturally this string over here will have 2T. So show 2T on M1 and show T on M2, which is over here. Now whenever you apply Newton's laws, always take the direction of acceleration as positive. So this is the supporting or helping force minus the opposite force. Net force is this whole thing is mass into acceleration. Here there is only one force, so T is mass into acceleration. That's all. I hope this is clear. Everybody with me on this? Understood? Clear? Can we move ahead? Yes? Let me make some more blank slides. Meanwhile. Okay, great. Now you can have such multiple systems, pulley systems, and easily you can find the acceleration. Maybe I have a question like this. Imagine there is a block maybe I can take a pulley here, all right, then a pulley here, maybe like this, which is connected over here, and then maybe there is a pulley here, okay, something like this, and maybe this mass over here. Let's say this is M1, let's say this is M2, this is going on this smooth surface, and this is connected over here. All right, so what if I wanted to know what's the relationship between their accelerations? Okay, so brainy gamer, there is a link in the description box. You can join vPro, my batches very easily using that link. If you're not able to find it or you're confused, just probably leave a comment. I will try to reply to your comment after the video ends. Rashmi Sheikh, I did not forget you, bacha. Oh, I'm so sorry if I missed your chats. I definitely remember you, bacha. I don't forget my students. Yep, welcome, bacha. All right, so now what you need to do is to find the accelerations, ratio or the dependency. Draw the free body diagram, everything will be clear. Like for example, think and tell me how many strings are there in this problem. How many strings can you see connected between M1 and M2? Is it 1, is it 2, is it 3? Come on, put it up in the chat box. I have a feeling this string goes like this, like this, like this, like this. Oh, there is only one string. Great. So the tension is same everywhere. So if you look at it, there will be some tension over here. Okay, the same tension will go like this. The same tension here, and the same tension here as well. So this is that one single string right over here, right? This is the tension T, 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 T everywhere. If you just look at the free body diagram of M2, only tension wise, there is this tension T from here, but remember this pulley will apply a force of 2T like this on this point. So the pulley on the block will pull it this way by a force of 2T. T will become 2T over here. So between these 2 points, the tension will be 2T. Are you clear about this? Excellent. And if you look at M1, I have a feeling there is only one tension, so just put T over here. So now if you look at the total tension over here, what is the total tension over here? It is thrice T, and this guy accelerates this way, this guy accelerates this way. Think, how do you find the accelerations relationship? If the tensions are T, 2T, accelerations are 2A, A. So if the tensions are T, 3T, T, 3T, then what will happen? If this is T and this is 3T, this will be A and this will be 3A. Simple logic. I won't teach you difficult things. I won't make things complicated. Easily in the exam you can solve it. After this you can write equations and solve them. Yes, Asing, I'm back. Is that clear? Understood how to solve multiple pulley problems? Everybody with me on this? Okay, beautiful, amazing. Okay, right. So, moving on. Anything else that you have doubts in, please let me know. Can you join the JEE crash course right now? I wouldn't say you guys to join JEE crash course right now, bacha, because now is still the time. There is a not a very long-term batch, but not a crash course kind of batch. There is a middle kind of batch, which is not a crash course, but which is not a long-term. So that is a batch which is going on. That is something which you can join, Nahit Reja. All right. So how about I give you now some homework for you guys to try out at home? Yes. Yep. I'm going to give you a PDF which will have some questions. All right. So there will be a PDF of some questions. I'm just going to put it up over here like this. So I want you to solve this questions. I'm not going to show you the entire PDF right now. The PDF will be uploaded in the Telegram channel. Yep. So please try to solve it. All right. Lift cases. Okay. I will solve some lift problems as well. Okay. So let's say for example, I have a lift. Let's say for example, I take a lift like this. Okay. And let's say there is a string and there is a mass, okay, and this lift, let's say, accelerates downwards. Now, whenever you have lift problems or moving car problems or accelerated frame of reference problems, there is a wedge on that, something is moving. So you have to think of pseudo forces. So the simple concept is like this. Whenever you have to think of pseudo force, remember, you will have some accelerated frame. What is the accelerated frame called as? What do you call the accelerated frame as? An accelerated frame is just called as non-inertial frame. It is just called as non-inertial frame of reference. In this frame of reference, is Newton's law valid? Nope. Newton's laws of motion, they are not valid. So what do you do to make them valid? You make use of pseudo force, a fake force. It's just a force on paper, it's not reality. So you make use of pseudo force, and when you use that pseudo force, suddenly Newton's laws of motion become valid. That's what it is. So whenever you have an accelerated frame and you are looking at any body, and let's say the frame's acceleration is somewhat, let's say, like this. This is the acceleration of the frame. What you do is you always apply a pseudo force Fp, P is silent, Pseudo, P is silent, that's how it's pronounced. It's always opposite to the acceleration, and the magnitude is basically the mass of the body into the acceleration of the frame. It's always opposite to where the frame is accelerating, and the magnitude is the mass of the body into acceleration of the frame. Cool. Now if I try to apply pseudo force concept in the lift, for example, it is accelerating down. Think, what are the different forces? One is nothing but mg, next is nothing but tension, and there will be one more force. That's pseudo force. If I sit in the lift is accelerating down, pseudo force will act up. So there will be a pseudo force acting up, which is equal to mass into acceleration of the lift frame. Inside the lift, so when I am an observer, imagine that Pandu sitting inside the lift. For this observer, this mass is obviously going to be at rest. So basically it is at equilibrium. And at equilibrium, what should happen? All the forces should cancel out each other. So I will easily say the pseudo force plus tension is equal to the weight. Pseudo force is mass into acceleration, so plus tension is equal to mg. So tension will be equal to m into g minus a. So that's how I can solve the problems on a lift. Maybe I can take another question so that you understand this better. So pseudo force is not a real force, always acts opposite to acceleration of the frame, and it is mass times the acceleration. So let's say, for example, I have a question maybe like this. Okay, imagine I have a wedge, okay, and maybe a thread, and maybe somebody is pulling that thread by a mass, okay, and maybe there is a mass kept on this as well. This is m1, this is m2, this is capital M, and I'm pulling this thread by suspending this mass like this, such that this m1 doesn't slip on capital M. So what will be the criteria for such a thing? It's going to be crazy. If you use inertial frame, then how do you solve it? If you use inertial frame, okay, I'll come to that, bacha. See, if you use inertial frame, imagine you take a observer who is there on the ground. This is basically inertial observer on the ground. Then what happens? This same free body diagram will become like this. Mg will be as it is, tension will be as it is, pseudo force will not be there because you are inertial. The only difference is now you will see the mass coming down with the lift. You will see the mass coming down with the lift. So you will just show the same acceleration of the bob. Here you will say mg minus t, big minus small force, is mass into acceleration. Rearrange, you will still get tension is equal to m into g minus a. It's not different. You will still get the same answer. You will still get the same answer. Okay, so it doesn't matter which frame you choose. All right, so if you have this kind of question, what you will do is think about it. If this moves together, if M1 does not slide on M, then M1 and M move together. So what you can do is you can consider them like one single system. You can consider them like one single system like this, and on this capital M plus M1, the forces will be, there will be a normal force, there will be weight vertically, there will be tension, and this whole thing will definitely accelerate, will definitely accelerate like this with some acceleration A. Right? This is how it will accelerate. The same tension will continue here, and on M2 you will say tension is there here and M2G is there over here. Tension is there here, M2G is there over here, and this will accelerate downwards. So using simple logic, you can write equations like M2G, bigger force minus smaller force, is mass into acceleration. Just Newton's law, net force is mass into acceleration. Here you can just say tension is equal to capital M plus small m1 into acceleration. That's one equation. Another equation, what you can write is for this small m1, look at this. If you look at small m1, okay, the small m1 which is just sitting over there. Imagine I sit in a non-inertial frame. That means I sit on the capital M mass. That means the moving accelerating wedge, which is definitely a non-inertial frame. In this non-inertial frame, there will be one extra force. I have to keep that in mind. So M1 will definitely experience two components of weight. One is your M1G cos theta and M1G sin theta. You will also have normal over here. You will also have normal. If you don't want to write the components of M1G right now, fair enough. I can show it later on also. You can just think there is one weight downwards to keep it simple. Okay. And now you will show, because it's a non-inertial frame, you are going to show a pseudo force. So guys, this man sitting on this capital M is accelerating this way. So hence, where will the pseudo force act? The pseudo force will definitely act this way. The pseudo force will act this way. It will be mass of this guy, so M1, into acceleration of wherever you are sitting. So you are sitting on that combined system which has acceleration of A. That's what the equation will be. Now if you want, you can split the forces. I think it's better to split normal over here than the mg value. So you can drop vertical and horizontal lines like this. You can clearly see that if this is theta, 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 this is theta. So you can see that normal has two components. One is n sine theta, because this is theta, and this is basically n cos theta. So you can make whatever equations you want. Like in horizontal direction, you can say m1a is equal to n sine theta, and in vertical direction you can say n cos theta is equal to mg. You can divide that and you can see n by n sine theta by cos theta is equal to mg by m1a. So n cancels. This will become tan theta is equal to just check this out. Right, everything is fine. Sorry, I think I put a and g opposite. This should have been m1, and this is a, and this is m into g. So basically tan theta will be nothing but a by g, and you will have m1 over here, and this mg is also the same mg. So actually this is m1g only. This is also m1g. So m1 also will cancel, my dear students. So I don't have to show it. So I got tan theta is a by g, you can use these equations to solve the question. So this is how you solve questions, guys. Draw FBD, split, make sure angles are right, use the appropriate forces. If it's a non-inertial accelerated frame, use pseudo force as well. Bhanu Prakash will be getting the notes in the Telegram channel, so join the Telegram channel. Anything else you have specific to ask, please ask before I end the class. I'm going to give you a PDF which has some questions which you can practice. Okay, some few questions will be there for practice, which you can download only in the Telegram channel. So make sure you join the Telegram channel as soon as possible. All right. Nihar Teja, I don't know, bacha. If we start, I'll definitely let you know. Okay, great. So definitely please join the Telegram channel, and there are some questions which I'm going to give you in the PDF in the Telegram channel. That's it from my side, guys. I hope you guys enjoyed the class, and make sure you smash the like button and also hit the subscribe button. That's it from my side. This was Captain Shreyas signing off. Hasta la vista.